Hi, welcome to the PerceptiLabs webinar. We are going to talk about the past, the present, and the future of artificial intelligence. When finished this presentation, we are going to learn how to create a deep learning network to classify type of skin cancer using a skin MNIST dataset. Okay, you are free to share in social media this webinar using a screenshot and adding the hashtag of PerceptiLabs. Okay, I'm David Millan. I'm a developer relationship of PerceptiLabs. I'm expert in computer vision and machine learning and co-author of different OpenCV books. I have more than 10 years of experience on IT working for different companies and startups from augmented reality to health. Okay, in this webinar we are going to show where artificial intelligence come from and get a bit of history of machine learning. We are going to talk about the present and the actual techniques, algorithms, and software and hardware that is used nowadays, and of course the state of the art of them. And finally we will explore the most close and not so close future of artificial intelligence. Finally, we are going to close the webinar with a small workshop that in few minutes we are going to create from scratch in a few steps a new deep learning model. I want that an interactive webinar, and if you want you can stop me and interrupt and ask me or put your questions in the chat. Okay, where does artificial intelligence come from? Artificial intelligence is the capability of machine learning to get intelligence. First concept of artificial intelligence appeared in the fiction, in the books like Frankenstein in 1818. But the first work that is now recognized as artificial intelligence was McCulloch and Pitts in 1943, formally designed for Turing-complete artificial neurons. Finally, artificial intelligence was founded as an academic discipline in 1555. Of course, we have to mention that artificial intelligence and machine learning are not possible without the math and statistics. Then this is our start point. Early of 80, the machine learning started to grow with any stop. We found that a lot of new methods and algorithms are used in real use cases. Algorithms like super vector machine, decision trees, bias, hidden model Markovs, or neural networks becomes very popular. All of them employed in use cases like OCR, image recognition, face recognition, and a lot of types of algorithms. Between these dates, a special year must be mentioned. In 1989, where Jan LeCun started to apply the backpropagation algorithms and create the first convolutional neural network. This means this is deep learning, and he applied in handwriting recognition, and this was very powerful and very important step. And the scientists detect that the convolutional neural networks and deep neural networks works better than the classical algorithms like super vector machines. That requires human preprocessing because we need to extract the feature before add to super vector machines. And the convolutional neural networks, he can learn these features. But why deep learning was not so popular in these years? First, because we need a lot of data, and the second, we need a lot of computation. Then, but the data in these years was not enough. We don't have enough data, and we need a lot of computation. That in these years, it's not a lot of enough computation for deep learning. We have different supercomputer, but it's not enough powerful to develop these algorithms, these deep learning algorithms fastly. Then the classical algorithms of super vector machine, neural bias decision becomes popular because this alone was not enough. Okay, but what happened in 2007 and 2010? Appears two revolutions. A lot of labeled data starts to increase, and another thing is the GPU's capability to parallel the process matrix operations. And this GPUs has enough power to compute the deep learning neural networks. And do you think that really this GPU has enough capabilities? Let's check this plot. In this plot we can see the most powerful supercomputers in the world. The blue line is the sum of the 500 supercomputers in the world, the capability of GPU, and the orange line is the best supercomputer. Okay, and in the horizontal red line we draw the capability of computing of only one NVIDIA GTX GPU. Okay, that it's around 10 billions of flops, 10,000 of gigaflops. Okay, if we check the plot, we see that only one NVIDIA GPU has more powerful than the best supercomputer in 2002. This is awesome. This is really revolution. It's a big revolution that a basic GPU has more powerful than the best supercomputer in the world. Then it's a revolution. And from this point, deep learning start to be more powerful algorithms. Okay. Now we check we are the past and the future of artificial intelligence. We check where we're from. We check the start of growing artificial intelligence in 18 and started powerful of deep learning that in last years. Okay, but we know really all that artificial intelligence involved. We know what all the market, the software, the algorithms. In the next slides we are going to discover the artificial intelligence, the market, the actual software, and the most used and innovative algorithms. Okay, in this graph we can see what is deep learning, okay, and artificial intelligence. This yellow blob is the artificial intelligence. Inside of artificial intelligence is the machine learning, and inside of machine learning is deep learning. But if we check, we have data mining, we have a big data analysis, we need the computer science, we need data visualization, neurocomputing, statistics, mathematics, high performance computing, cloud computing. What this means? That artificial intelligence requires a lot of things, a lot to acknowledgement and topics to know, to understand correctly what is artificial intelligence and more what is deep learning. And what's about the market? Oh, the market of artificial intelligence is very big, a lot of software. We require infrastructure that are Amazon, Google Cloud, SAP. There are a lot of technologies and a lot of companies working on. We need machine learning intelligence applications for healthcare, advertising, education, life sciences. There are a lot of software. And if we check a bit more about artificial intelligence, the analytical machine learning, that the most powerful components are there, like Microsoft or IBM or MathWorks or Google. And of course there are a lot of new companies that come every year, and there are companies like PerceptiLabs for artificial model development, or healthcare like health.io, Zebra. Then there are a lot of companies that grow every year. And what about the technology? What about the software that involves artificial intelligence? If we think in deep learning, all of us, we think in TensorFlow. But if we think in TensorFlow, we have to think in Python. And if we take a bit more, we have to think in C++ and C. And not is this the only technology. We have Keras, we have PyTorch, we have Torch, we have MXNet, or we have Paddle that is a China framework like TensorFlow. There are a lot of technologies, there are a lot of software and a lot of language involved in it. And there are new technology that becomes very popular in this last year, that it's ONNX. ONNX is an open neural network exchange. This is a standard for machine learning interoperability. This means that we can create or model in PyTorch or Keras or TensorFlow or scikit-learn, and we can export it in an optimized format to put in embedded devices or in servers. And we have to take good care because it's a very good software. And what about tools? There are a lot of tools that help us to develop our own neural networks or deep learning. The most popular, of course, is Jupyter, and Jupyter is inside of Google Colab and the Kaggle's platforms that are very useful platforms because we have a free tier of GPUs. But Amazon SigaMaker or Azure Notebooks or Google Cloud Platform integrates Jupyter and has a good point to start to develop our algorithms. But there are new tools like PerceptiLabs that helps us to create our deep learning neural networks in very easy and in few steps that we will check later. But as we said before, and we see in the plot, we think in artificial intelligence, we have to think in data, and data we have to think in big data. Big data we have to know Spark, we have to know environments like Spring, OpenStack, Docker. We have to think in where we have to save the data, like Mongo database, HTTPS. There are a lot of technology that we have to know. Okay, we check a bit of tools like TensorFlow, Paddle. We know tools like PerceptiLabs or Google Colab. Okay, then we are now go inside of algorithms. Then we have the tools. In the next slides, we're going to show different techniques and deep learning algorithms and use cases to apply or develop models. Okay. The first thing that we have to do is create our model and develop it. We can use tools like PerceptiLabs or code it or Google Colab. And after create all this, we have to train it. We have to put into train all algorithm, and oh my god, when we I create a big model and we put to train this model, and this take a lot of time to train it. Then there are a solution that is use transfer learning. Transfer learning, and that's a very useful technology. This technology is that someone create a very big model and train with a very big data set, a generic data set, normally it's ImageNet or something like similar, and they train this model and save this weights and biases of the model, then save the model. And then you can use this model to train your own model. And then what you have all the features that this model learned. All the features it's learned, and then you only have to learn the last layer, how to classify your network. Then this is very useful, and we can use transfer learning to develop our own models very fastly and with low computation. We can see in the workshop how we can create a transfer learning. Okay, but what algorithms there are? If we want to use object detection or object classification, there are algorithms like YOLO version 3, 4, 5 or CenterNet that has the capability to detect in an image where is an object and classify it, and they are very useful. I said algorithms like YOLO are very powerful to do this. There are another type of algorithms that are GANs, okay, or discriminated learning, that he tried to learn features and after that to trying to decode these features, and this is very useful, for example, to make a segmentation, or for algorithms like translate to, or for example deepfakes, like this video that was very funny.
Cohen is producing a show for Netflix. It's about a women's wrestling show from the 80s, and I was kind of like, what an idea! And they were like, no, it's a real thing. And I started.
Okay, there are more deep learning algorithms like natural language processing. There are very powerful algorithms that it's GPT-2 and 3. BERT, for example, that has a big deep learning network with millions of parameters to train, and he can auto-complete your text. He can learn to create new text from small paragraphs or small sentence, and this is very useful. And if you have to create something for natural language processing, I suggest you to learn GPT-2 and 3 and BERT algorithms that are very funny and very powerful. There are no algorithms that are reinforcement learning. Reinforcement learning is an area of machine learning concerned with how intelligent agents have to take actions about the environment, and in order to maximize the reward. Okay, I want to show a video that there are two teams, a blue team and a red team. The blue team has to hide from the red team. Okay, and he can use walls, he can use anything that in the environment to hide from the red team. Okay, I'm going to this the video.
On Earth, the simple rules of natural selection and competition
moments, the algorithm try to learn. Then in the first moment he don't know how to hide from the other team, and then fastly they are found. But if we put the video more later, then the blue team learns how to move blocks and put in the doors that the red team cannot see. But if we put more later, we saw that the blue team can create his own doors to done his. Then these algorithms can learn how to interact with the environment to do this. This is awesome. Okay, this is a very useful video. Okay, another algorithms that are very useful is the temporal series. The most important is LSTM, long short-term memory. This deep learning algorithm, it's very useful to train a very small or to train a temporal series and predict what will happen later. For example, if we get the historical of Bitcoin, for example, we can predict what will happen in the next days or months with this type of algorithms. Okay, we saw about algorithms. What we are going to learn a bit what are in the hardware. In the hardware we have two types, for inference and for training. Of course, for training the most important is NVIDIA. We have Titan X, GTX or Tesla, that are the most important. AMD has his own graphic card for artificial intelligence, for deep learning and computing, but it's not so popular. And of course we have Google TPU, that's very popular and very powerful, and Intel has his own GPU for intelligent artificial, but not so popular than Google and NVIDIA. In other side we have for inference that are embedded devices like Google Coral, that is a format that has a small TPU inside and has the format of a Raspberry Pi. We have NVIDIA Jetson and NVIDIA Drive. NVIDIA Drive is for cars driving, okay, as auto drive, okay. And there are very powerful chip that from Intel, sorry, that is a Myriad Movidius, that this is a small chip that you can buy the chip only and put and embed in your devices like phones, or you can buy the USB stick and put in your computer for inference, only for inference, not for training. But a bit more of future, the future of hardware, we can find a near future that it's optimizes hardware. This is a only chip, a very big chip for training algorithms. That it's a 2.6 trillion of transistors, optimizes for artificial intelligence. This is very powerful and of course expensive. Okay, about the software or not so software. Okay, but we have to take a bit of future of artificial intelligence. One, it's federated learning. Federated learning, it's not so future, it's present, okay, but it's how you have to train your own model with a private data. Then you can put your model in the devices or the computers of the user that has the private data, train it there, and import the weights of your model in a center software. And then you train your model with all the weights of the other softwares, and you get more powerful. And this is very used in, for example, hospital or agencies that they don't want to share the data. Another part of this that it's the present and future. It's what happens to them when artificial intelligence has to take a decision. What happens if he has two decisions? What he has to do? And of course, and when I have to take this decision, imagine that we kill some of them. Who is the responsibility of a car hits a pedestrian? Who is the responsibility? The software, the human that is in the car that don't push the brakes, the company of the car. Then this is something that is very critical. And very, very future, that it's not so here, this is a very future, it's a quantum computing. Quantum computing is a very powerful computing that can change all things about the computation resources, and it's very important to take care. Okay, then we finish to this presentation. We are going to create in very few minutes or use cases about skin cancer classification. Then let's go. Okay, then first we are going to create a new model. Okay, we are going to use PerceptiLabs software. First we are going to do is load the data. Okay, then PerceptiLabs skin cancer. Okay, and we load the CSV. Okay, confirm. Okay, we here the list of images. Then is the type of image, and this is our input, and this is the label. Then we are going to put as target. Okay, this is very fast. Okay, next. After that, we have to name of model use case skin. Okay, number of epochs. We are going to use transfer learning. Then we need very few epochs. Okay, and the other things we are going to okay, the loose we are going to use cross entropy because it's a classification. Okay, and then we can choose run model directly, but we want to customize it. Okay, customize. This will take a few seconds to create. Okay, here. So we are going to stop this and continue here. Okay, initially PerceptiLabs create us for us a network that has the input and has the output and has the first convolutional layer and two dense layers. Okay, this is something that we don't want to check. Okay, then the first we are going to do is delay this layer, and we are going to use transfer learning. Then we are going to deep learning. Okay, deep learning, and we have different transfer learning. We are going to use mobile net. That is a good transfer learning. Okay, and after that we are link our input with MobileNet and the MobileNet to the output. Okay, then we have our MobileNet here. We don't want to add the weights, we want to the weights of ImageNet, and we don't need to include the top. This means that we want to customize our last layers. Then the last layers we are going to add a dance with 512 layers, okay, 16 with a ReLU, and another we are going to put 7, that is the last layer. This is 7 classes for us, and we are put softmax. When finish this, we have all our network created. Then we can start to run. He said what the parameters we want to change, in our case not. Okay, this is start to train. We start from 0. We have here the layers. Then this is the output for the first iteration, the weight and the gradient for a selected node. And then if we choose this node, we have the output, the weights, the gradients for this layer. Okay, then we can go to global. The global is the loss metrics. We are working in the first epoch. We see that we are in the first epoch with the 41 iteration. Okay, we see that the epoch was decreasing very fastly because we are using training transfer learning. Then we saw that we are now around 1 or 0.9 loss error. Okay, this is working very fine. Then we are going to wait few seconds to finish the first epoch. Okay, here we can see another layer, that this is the outputs, the weight, the gradients. All these tools allow us to debug what is happening inside of our networks and if it's training correctly or not. We can go to the target. The target is the accuracy for this iteration. We are in the first epoch, and if we put the mouse here, we see that now in the training it's around 56% of accuracy. That for first epoch it's working very fine. Okay, and we can go to the input, and the input is the image for this epoch. We are going 2%. Okay, let's go to check, and we continue decreasing the loss. This is working very fine. Okay, we finished the first epoch, and we can check the loss for the first epoch, that is this 0, and we see that for training we have a 1.3 of training loss and 0.7 for validation. And if we go to the target, we can check the accuracy for the first epoch, and we see that we have a validation of 0.71. This is 71% of accuracy for the first epoch for validation, and from training 65% of accuracy. This is awesome. This is working very fine for the first epoch. If we check now that is training the second epoch, we are 78% of accuracy, and if we continue training, we will reach around 18% of accuracy for only a very fast develop of this transfer learning algorithm. Then this is all. I hope that this will be helpful for you, and I expect that do you like it. And if you have any query and you want some more information, you can write to me to david.e@perceptilabs.com, or send any question to our forums or Slack channel. Thank you to you. Bye.